All right, 18.5, here we go. Solving right triangles. All right, so we are going to solve now using sine, cosine, and tangent functions. If you recall, sine theta was opposite over hypotenuse, the ratio of opposite to hypotenuse. So it's just a number. Sine theta is just a number. And what you end up with are three variables. You have theta as an angle measure, you have opposite, and you have hypotenuse, which are both just side measures. All right, and the same thing goes with cosine. You have an angle, and then you have an adjacent side divided by a hypotenuse. So again, you have three variables, your theta, your a, and your h. Just like we had with sine theta, your o and your h. And then tan theta, again, theta, the angle measure, is a variable, and then opposite and adjacent are both side measures that are variables. So what that allows us to do is with three different variables, if we know two of the three, we can solve for the third, which is all what trigonometry is about. It's the study of the measure of triangles. So we can use it all over the place. And we're going to just try basic triangles now, and then 18.6 is actually using what we have to find measures in nature. Like if you come across a river and you are like, oh, I don't know how far across this river is, but I want to know because I know I can swim at least 20 feet, but other than that, I can't. I don't trust myself. So you can mark off a certain measure. You can mark a side at one point, like with a stick or a flag or something, and then you can measure off like 5 feet to the right. And then you can take that and use a clinometer, they're called, an angle, and come up with an angle to the point directly parallel on the other side of the river, exactly opposite where your flag is, and find the angle from where you're at to that point. And you would be in good shape to come up with the measure of the river without actually crossing it or dropping a tape measure or something. So we can use this in nature all the time. When people who are geologists or whoever does this, they always want to figure out how much erosion happens, like with the Delicate Arch in Moab. So people go out and they would not go on top of Delicate Arch or cause anything or do anything that might cause some damage. Instead, they'll use right triangles to come up with the actual width or length of the Delicate Arch there at the arch and see how much erosion has happened year to year. And they do that all indirectly using trigonometry instead of actual tape measures and things. So very, very useful. Another thing they do, of course, is figure out how far away planets are without actually traveling there. They'll use right triangles. They've used right triangles in trigonometry to come up with the diameter of the Earth and the radius of the Earth, just by using those right triangles and parts on the Earth between cities and how many miles difference they are. And it's just an amazing what they've done. And these are people who didn't have calculators, who lived hundreds of years ago, thousands years ago, who came up with the actual radius of the Earth, and very close to what they assume it is now, without actually traveling to the center of the Earth and without having calculators or even pens or paper. It's just amazing what you can do with trigonometry. So air traffic, air travel, space travel, all using trigonometry. Pretty cool. So we're going to look at just the basics today, and then on your next lesson, 8.6, I think we're at 5 now, yep, 8.6, we're going to look at some application problems. So find all missing side lengths and angle measures. So when we're finding side lengths, we're going to use these nice little trig functions that I wrote out up at the top. So example 1, what we do is we look and we find the angle that we know. So that's 48 degrees right there. That's the angle we know. And then we look at what sides are involved. And I say that because one side we'll know, one side we won't. So we just look at the two sides and figure out what they are. So from this angle, we have an opposite side and we have an adjacent side, O and A. So we label the sides. And then once we've labeled the sides, we come up with which of those three trig functions we have the sides for. And that one, in this case, O and A is tangent. And that lets us know which of the trig functions we're using. So we'll do tangent. Now, always what follows the function is the angle. So tangent 48 is equal to opposite, which is x, over adjacent, which is 17. So far, we've labeled the sides, we've determined which function, we've written an equation, and that we can solve for. We can solve for x. Now, solving for x, we remember that even though tan has some variables in it, well, not variables, but it has letters T, A, and N, it's not a variable. It's just tangent 48. You can put tangent 48 in your calculator and come up, and it will tell you the ratio that belongs to an opposite over adjacent side of a 48-degree angle in a right triangle. It will tell you that ratio. It's the same every time based on similar triangles. So it's just a number. So don't look at it as a variable or anything. The only variable in this whole equation is the x. So we're going to solve for the x. And how do we solve for the x? We multiply by 17. Because x is being divided by 17. So that means x is equal to 17 times the tangent of 48 degrees. And that we can put in the calculator. We just have to hit tangent. Let's see, tangent 48. Oh, and before that you hit 17. I didn't tell you that. So 17 and then tan 48. And you don't even have to do times. It knows when it has a 17 butted up right next against the tangent that it's multiply. And that's approximately 18.88. And it doesn't say what to round to, so I'm just going to round to 3 because when you get into calculus, that's where you'll do 3 or more with your rounding. And that's how you do. So finding side lengths, I'm going to just write out the steps real quick, what we just did. Where would I have the most room? At the top? Probably at the top. Okay, so the first thing we do, I hate it when it does that. I'm not dealing with that. Anyway, maybe I'll write it over here. Label OAH, and then figure out which trig function to use, like sine, cosine, or tangent. 3 is write your equation, and then 4 is solve for x. Okay, and that's all you're going to do. So in X1 example 2, we have our angle here. 67 degrees is our angle. So opposite is that one, and hypotenuse is that one. So we have O and H, opposite and hypotenuse. So O and H belong to sine. So COTOA sine is opposite divided by hypotenuse. So we'll use sine. So we labeled O and H. We figured out the trig function is sine. We write sine and then the angle. Angle always follows the sine, and that's equal to opposite over hypotenuse, x over 29. And then to solve, next step is to solve. We're going to multiply by 29, both sides. So x is equal to 29 sine 67 degrees. Okay, and then over to your calculator, type in 29 sine 67, hit enter, and x is approximately 26.695. All right. And we're done. Woohoo! Example 3. Example 3. So this side, here's our angle, 37 degrees. That's going to be the hypotenuse. And this side is the side that's running right into 37. It's the leg that runs into it, so it's adjacent. And we have A and H belongs to, if you can remember, ka, so COTOA. Cosine is adjacent over hypotenuse, so we know it's the cosine of the angle, 37 degrees. So remember, cosine angle equals A over H, 48 over X. All right, so now solving when X is on the denominator. Notice in our other cases, X was not in the denominator. X was in the numerator, and then see how X is in the numerator, X is in the numerator. Here we have X in the denominator. So I'm going to show you once what to do, and then I'm going to point out what you can do forevermore. When you're solving for x in the denominator, you multiply by it. It's the only way to get it out. So to get it out, you're going to multiply by x. Dang it. Just, it's so weird how that just takes it on down right from that left side. So that goes away, and you have x times the cosine of 37 degrees is 48. Okay? So then, moves it up there. How obnoxious. That's so funny. Okay, cosine 37 is being multiplied by x. Now, cosine 37 is just a number, so you can just divide by a number. If it's being multiplied, you divide by it, and that undoes it, so undoes the multiplication. So our cosine's gone. Our x is equal to 48 divided by the cosine 37. All right? Now, what you notice from the beginning, and I tried to leave it in a different color, but I did draw a line through it. What you had in the beginning is we had cosine 37 is 48 over x. In the end, we have x equals 48 over cosine 37. Notice that the 48 stays in the same spot, but the x and the 37 switch spots when you solve. That happens every time. If you have x on the bottom, just switch it with whatever trig function is on the other side. So if it's sine or cosine or tangent on the other side, just switch it with the x, and then you don't have to go through all those steps. You can just switch and go, switch and solve. Just plug it in the calculator. Okay, after a while, if you practice a lot, you'll notice that when x is on the bottom, it's a divisor. You take the number and divide by the trig function. If x is in the top, then you multiply the number by the trig function. So it happens every single time. These are pretty simple. They're just triangles every time. If the x is in the denominator, just switch and divide. So you notice these two switched. All right, and then you can plug in the calculator. 48 divide cosine 37. And remember, cosine 37 is just a number. Notice even your calculator brings up a little angle space, puts a parenthesis to start it, and says, hey, you need to put an angle in there. So, and then finish it off. But you can just plug it in how you see it. 48 divide cosine 37 right there. And hit enter, and you get 60.1. 0.03. That's the length of that side, the hypotenuse. Okay, easy peasy. Now, example 4. Well, I have 2 minutes. I wonder if we can do it. Example 4 says find DC. That's right here. Now, all I have is an angle, and I need one more thing. I either need one side or the other. So on these, I have to figure out which side is going to help me. And this side is going to be my helper. I'm going to have to find that side and then use it as my secondary side to find DC. But I have to use trig to figure out with the left triangle that height of the triangle so that I can figure out the length of DC on the right triangle. All right, so on the left, we have this angle 48 or 54. The side I want is opposite. The side I have is hypotenuse. So that's a sine. SOHCAHTOA. So sine of the 54 is equal to opposite over 20 divided by 20. Opposite over hypotenuse. So this has the variable, which is O. X is what it normally is on the top. So it's a multiplier. So you just multiply both sides by 20. So opposite side is going to be equal to 20 times the sine of 54. So I'm going to figure out what that is, 20 sine 54, and that's 16.18. All right, and I'm going to write that right there. But I'm just going to leave it in my calculator because I'm going to use it here in a second. Now I want this side right here, second. So I'm going to use a different color, and we'll find that side now. So we have 28 degrees is our angle. This is opposite still, and this is going to be our adjacent, isn't it? It's the hypotenuse that we're not dealing with in this one. So O and A is tangent. So tangent 28 is going to equal opposite over adjacent, so 16.18 over x. This one has x on the denominator. So we switch and divide. So we just switch these two. We leave 16.18 at the top, and we put x equals 16.18 over tangent 28. All right, and put that in the calculator, 16.18 divide tangent 28. And that is 30.430. And that is what x is approximately, since we had to truncate or round it. Okay, and that is how you do the first part of 18.5. I think we're on 18.5. Anyway, so watch part 2 next.